Yeah, good morning, students. It's my pleasure to introduce this topic on dynamic memory allocation for two-dimensional arrays. So, in the previous class, we had a discussion on dynamic memory allocation functions, and also we discussed about how these DMA functions are used for allocating the memory for one-dimensional arrays. Fine. So, now I would like to share my screen. Hope my screen is visible to you. Fine. Yeah. So the current topic for discussion is that the week 4 lecture 1 dynamic memory allocation for two-dimensional arrays. So summary of the previous classroom discussion topic is that in the previous class we had a discussion on dynamic memory allocation functions like malloc, calloc and realloc functions. We have used that. And then free is a dynamic memory deallocation function that we have seen that, and how this malloc or calloc can be used for one-dimensional arrays that we discussed in the previous class. Now coming to this today's classroom discussion topic, objectives, lecture objectives is that dynamic memory allocation for two-dimensional arrays. How a two-dimensional array memory can be allocated by making use of this malloc function. Fine. The outcome of lecture outcomes of this particular session is that upon completion of this classroom discussion topic, students can be able to use dynamic memory allocation functions for double dimensional arrays along with single dimensional arrays also. Fine. So dynamic memory allocation functions, these we already discussed that malloc which allocates the specified number of bytes, and calloc which allocates the specified number of bytes, which, and by default they are initialized them to 0. Realloc which is used for increasing or decreasing the size of the allocated memory, and free which is used to release the specified block of memory which we have allocated. These we have already seen that. And now we would like to discuss about what is a two-dimensional array and how a memory will be allocated for a two-dimensional array, that we are going to see that. So when we are discussing a two-dimensional array, so the memory block of size we have to allocate, which is equal to row into column into data type size. So using malloc and pointer arithmetic can be used to access the matrix elements. So where row is the number of rows and column is the number of columns, and then what type of values we are storing into that particular array matrix. So that is the size of this particular data type. Fine. So we will see with an example program here. So because we are making use of this DMA memory allocation functions, dynamic memory allocation functions, all those functions are defined in the stdlib.h. So we are including that, and we are asking the user to enter how many total rows are there in the matrix and total number of columns are there in the matrix. So we are taking the input from that, and then we are allocating the memory which is declared it as a two-dimensional pointer. So int double star p. So now p is a two-dimensional pointer. Now we are allocating the memory. This is very important step. So int double star malloc, okay, int double star malloc row into size of int. So how many rows we are entered here? So size of int, this is the size of the data type. So we are allocating the memory. So p is a double dimensional pointer, so it is a double pointer, so we are typecasting to integer double pointer. Fine. So now we are making use of array. So now we are allocating the array of memory we are allocating. So for I equal to 0, I less than row, I plus plus. So p of I is equal to int star malloc column into size of int. So this is nothing but we are allocating the based on the number of rows, we are allocating the array of pointers we are allocating like this. So suppose we have row number of rows are there here. So here we are storing like this. This is a p array we are taking it as, okay. So this is p of 0, 0th row, p of 1, p of 2, p of 3. So like this here in this particular row, so it is pointing to the one dimensional array of integers, it is pointing to that. So that is the row 0 elements, it is pointing to that. So this is pointing to another row 1 in the matrix. Fine. So this is how it is pointing to again another one dimensional array which is equal to the column size. Okay. So like this we are allocating the memory for this. So now we are reading the matrix elements. For I equal 0, I less than row, I plus plus. For j equal 0, j less than column, j plus plus. Scanf percentage d star of p plus I plus j. So star, this will p gives the base address, and star of p plus I gives the particular row address, and j is the columns subscript. Okay, and I is the row subscript. So this is how we can get the address of an element belongs to the ith row and jth column. So this is how we are printing or accessing individual elements from this particular matrix which we have stored this. So we are making use of here star of p plus I plus j. So this is what the expression you have to understand to retrieve these elements present in the ith row and jth column. Fine. So this is for reading and this is for displaying. So once you understand this concept, now using this concept, now we can apply the matrix addition, matrix multiplication programs we can do by making use of this particular concept. So if you see this program on matrix addition using dynamic memory allocation, so we are taking three double pointers we are taking because to read two matrices here. So we are allocating the memory as similar to that P matrix, and then we are reading that elements, and then we are taking this Q and we are allocating this Q matrix here. So second matrix we are allocating here. Fine. So this is what we are doing here. Second matrix allocation Q. So once you understand this previous program what we have seen, so it is same concept we are using here to access and to display and as well as to read these elements. Fine. So this is what the concept here we are using, and so we are allocating this third matrix R. So the resultant matrix we are storing this R into R matrix we are storing that. So star of R plus I plus j is equal to star of P plus I plus j plus star of Q plus I plus j. So this is what we are using this dynamic memory allocation to add these two matrices. Fine. So this is how you can do that. So this is an example program demonstrating how the matrix addition can be done using dynamic memory allocation. Fine. So this is what the reflections part 1. So write the statement to allocate memory for a 2D array of size 4 cross 3. So 2D array of size 4 cross 3, if you want to allocate the memory for this matrix using DMA, dynamic memory allocation function. So can you tell me what is the statement we can write it as? Anyone will have an idea? So P is equal to int star. So we have int double star. Okay. Then what we have done that. So once we did int double star, we are typecasting that, and then malloc of number of rows. How many rows we have? So we have 4 rows. Okay. Malloc of 4 into size of int. Okay. 4 cross size of int. Fine. So once you did this, next we have p of I for loop you can take, you allocate the columns. Fine. So the lecture outcomes are revisited here. After completion of this session, students will able to make use of this dynamic memory allocation functions for implementing this two-dimensional array operations like matrix addition, matrix multiplication, etc. Fine. So summary of this session is that in this particular session we had a discussion on how this dynamic memory allocation functions are used for allocating of this memory, malloc how we can use, and the free which the memory deallocation function which is used for deallocating of the memory, that we discussed in this particular session. Fine. So this is a lecture level practice problem. Write a program to multiply two given matrices using malloc dynamic memory allocation function. Fine. So hope you will solve this particular problem. So this is our further readings on this particular topic. So thank you one and all.